this is the chapter name called circles. Okay, what is a circle, Laiba? You actually have studied in previous grades. It is nothing but, what is a circle, Laiba?
It's a closed figure with zero.
Yes, this is a closed bound figure which is drawn from, there is a center there, right? How do we draw a circle?
With a radius.
There is a center and it is just rotated throughout, right? That center, there is a fixed size, the center of fixed size, and there is a radii which is rotated throughout, and it forms a closed figure which is called as a circle, right?
Yes.
Okay, mashallah. So, in previous classes, you have studied actually about the chord. Do you remember what is a chord? Can you please tell me what is a chord? Okay. So we studied circles as a bound figure, right? A circle, it's nothing but a curved, it has a curved line in which all the points in the circle are equidistant from the center, and this way, right? All these are radii, what I'm drawing now, correct? These are all are equidistant, right, beta? They are equal distant center point, right? Radii are always equal. Whenever you draw in the circle, the radii, all the radii in the circle are equal. Okay, from whichever point, from the center to whichever point on the curved surface of the circle you draw a radii, that radii will be equal always. Okay, now we will see what is a chord. What does a chord mean? A chord is nothing but it is a line that touches 2 points on a circle. Okay, right, beta?
Yes.
Okay, for example, if you have these points that are touching 2 points in the circle, this is a point, this is a point. Okay, the one that passes to the center of the circle, okay, this is called as a diameter. What is it called?
Diameter.
So diameter is a largest chord in the circle. Just remember this. It is that largest chord in the circle, right, Vita?
Yes.
Why is it largest? Because it is at the most peak of the circle, right? The center of this parts of the circles are having the most high dimension, right? The center which passes through the center. Even this in this way also you can draw, in this way also you can draw. This is a major arc, or this is called as a diameter. This is a major chord which is also called as a diameter. So what is a chord? Chord of a circle is a straight line segment whose endpoints both lie on the circles. Fine? Both of the endpoints lie on the circle. Endpoints of this chord lie on the circle. Endpoints of this chord lie on the circle. Okay? So the chord that passes through the center of the circle, any chord in this way, or in this way, or in this way, if this chord passes to the center of the circle, then it is called as a diameter. Okay? Which is the largest chord in a circle? I just told you which is the largest chord in a circle.
Diameter.
Excellent. Diameter is the largest chord in the circle. Okay, because it passes to the center of the circle, it is called as the largest chord in a circle. So tell me, Laiba, tell me what is a again?
What?
What is a chord, beta? Let's revise. What is a chord? It is nothing but it touches its endpoints touches. Yes, it endpoints touches the circle, right?
Yeah.
Okay, and this way. Okay, what is the largest chord, beta?
Diameter.
Why is it called as the largest chord? Because it passes through the center of the circle, right? Because it passes through the center of the circle, so it is called as the largest chord. Okay, the subtopic that you're going to have regarding the chords in your chapter is nothing but the angle subtended by a chord at a point. Okay, you're going to study about angle that is subtended by a chord at any point. Okay, so how can we measure the angle that is subtended by this chord at any point? So what we do here is, beta, this is a chord, right? Let's name it AB. Okay, let's have some point in a circle. For example, let this point be C. Okay, Laiba?
Yes.
If we consider two lines, to this, if we extend two lines to this chord, then AC and BC are two lines now, right? This AC and BC are two lines now, right, beta?
Yes.
Yes. If we see the angle, if we see this angle subtended by this chord, then angle ACB is actually called as the angle subtended by the chord AB at point C. Okay? This angle ACB is nothing but angle subtended by the chord AB at point C. Fine?
Yes.
Okay? Angle subtended by chord at point C. Okay, so we are studying this concept, that is angle subtended by a chord at some point. Okay, so angle subtended by AB at point C is, what is the angle? What is the angle, beta? Angle subtended by chord AB at C is, tell me the angle. Angle ACB is an angle, that's all. Understood?
Yes.
Okay, if I draw a point O, okay, now please tell me what is an angle subtended by chord AB at point O?
AOB.
Excellent. This is an angle AOB. Okay. So we are going to study about this angle now. Angle AOB or angle ACB, etc. etc. Okay. Understood?
Yes.
So this is a concept now that we are going to start. The first subtopic that you have in your curriculum is angle subtended by a chord at a point. Okay. So we are going to study about that. So this is it. This is about this one. Okay. Angle subtended by a chord at a point. It is nothing but if we have a circle. Just now I told you. So now tell me, which is an angle subtended by PQ at R?
PRQ. Angle PRQ.
Excellent, excellent. Angle subtended by R by chord PQ at R is angle PRQ. Excellent. Now tell me, what is the angle subtended by chord PQ at O?
POQ.
Excellent, better. Very good. This is what it is called about angle subtended by chord at point at some point. Okay. Now tell me, what is an angle subtended by arc PQ, chord PQ at yes?
PSQ.
PSQ. Excellent. This is what we are going to study now about this, the same thing, the angle subtended, about these angles that are subtended by this arc PQ. Okay. Now PQ is actually the main thing that we are going to study. The other thing is the angles that are subtended by it. Okay. So which is an arc here, beta? Which is a chord here? Actual chord here in this figure? Actual chord that they're taken, PQ, right?
Yes.
PQ is an actual chord. From there, we are going to subtend other sides, other angles. Okay. So POQ is an angle subtended by chord PQ at center O. PRQ and PSQ are respectively the angles that are subtended by PQ at the point R and yes. So understood? So what is the meant by angle subtended by chord at a point? Understood, right?
Yes.
Yes. Okay, mashallah. So we will now go quickly see the okay. One fact that is being said is nothing but if you draw two or more equal chords, okay, if you're going to draw two equal chords in a circle, equal chords का मतलब क्या होता है? Same dimension, right? For example, यहाँ से यहाँ तक, if you draw 2 centimeter chord, beta, and if you draw 2 centimeter chord here, okay, Laiba, if you're drawing 2 centimeter chord here, okay, okay, then you're drawing a point at the center and fixing all of these and subtending all of these angles here. So the angle formed by this chord, and this chord are all equal. Okay. Okay, Laiba?
Yes.
We are going to prove that. Don't worry. I'm just going to tell you what it is. Okay. What it is. Actually, the angle that is produced by all of these chords will be equal. Why it will be equal? We are going to prove it. Okay. Inshallah, we are going to prove in next theorem. There is a first theorem which states this one. So if you draw two or more equal chords of a circle and measure the angle subtended by them at the center, even if you draw in here now, and if you go to measure it with your protractor, measure it with your protractor, then you'll find that the angles are equal. Okay, understood?
Yes.
Okay, the condition is that these chords should be equal. AB should also have 2 centimeter, FE should also have 2 centimeter, and this should have 2 centimeter. Then all of this angle, for example, if this is 60, then this is also 60, and this is also 60. Understood?
Yes.
In this way it works. So you will find that the angles obtained by them at the center of the circle are equal. Okay, all of these angles will be equal. Now let us give a proof for this fact. Okay, the proof for this fact is given by theorem number 1. Okay, the theorem number 1 states that equal chords of a circle subtend equal angles at the center. Have you understood this, beta? Have you understood this statement of the theorem? What is it telling? If you have a circle and if you are drawing equal chords in it, for example 2 centimeter chord and 2 centimeter chord, okay beta?
Yes.
And if you join it to the center of the circle, or the angle subtended at the center of the circle is nothing but this one, this is this angle and this angle, if you write AB, AOC and AOBD are equal, right or wrong? BOD are equal, right or wrong beta? Correct, right?
Yeah.
Have you understood this concept?
Yeah.
Are you clear? Now we are going to prove why these angles are equal. How can you please tell me how can you prove this? Can you not take two triangles and just apply ASA or some postulate and just prove it? It's very, very easy theorem, okay? Have you just understood the statement?
Yes.
You should have equal chords. Equal chords का मतलब है you have equal chords, right? If you have equal chords, then what else have they told you? If you have equal chords, then the angle that they are going to subtend at the center of the circle, this should be important. Center of the circle, you have to mark a center, and then angle subtended at the center is nothing but this angle, right beta?
Yes.
Yes, for the below arc, this is the angle that is subtended. So this angle subtended are also equal. Okay, this we are going to prove now. So chalo, it's very easy theorem. Come on. So we will take a circle. Laiba, understanding this concept, let's take a circle. We are going to draw two equal arcs. Let this arc be around 4 centimeters, just for example, okay? You can just take an example. AB is equal to CD. You have to draw two arcs. Fine? So tell me what two arcs did you draw now? Is it AB and CD? What is the statement, beta? AB should be equal to CD, right?
Yes.
If you draw AB equal to CD and then subtend an angle at the center of the circle from the endpoints to endpoints meet at the center. If you have subtended these angles at the center of the circle, then these angles should be equal. How to prove this is now we are going to consider two triangles. How? Come on, Liba, tell me two triangles. Name the two triangles that we can consider here. Triangle AOB and triangle?
COD.
Triangle AOB and COD. Yes, excellent, Peter. Then what we can say? Okay, in triangle AOB and triangle COD, what we can say, beta? What becomes equal, beta? We know that given. What is given? AB is equal to
CD.
CD because the chords of the circle are equal, right? Chords are circle. We have drawn equal chords. First thing is done. This is equal to this. But we also know what is AO and OD. Are they not the radii?
Yes.
Yes, AO, radii is always equal in the circle. We have to remember this. AO is equal to OD and also OB is equal to OC. These are also the radii, right? 1, 2, 3,
Yes.
1, 2, 3 lines. 1, 2, 1 and 1. This and this are equal. This and this are equal. This and this are equal, right? Now we have three sides equal. Which postulate can we apply?
Yes.
Excellent. Yes, this is from yes, this is postulate. We can prove that triangle AOB and triangle COD are congruent to each other. If these two triangles are congruent to each other, we have CPCT. What does CPCT states? Congruent or corresponding parts of congruent triangles are equal. So corresponding parts, matlab, the angles, all the angles will become equal. Angle A will be equal to angle C, angle B will be equal to angle D, and then this angle will be equal to this angle. So hence we have proved that the angle subtended by the arc is equal. Understood? This angle is equal to this angle. Understood, beta? Understood theorem? It is very easy, correct?
Yes.
Any doubts in it?
No.
No. So statement is equal chords. You have to draw equal chords and they have to subtend equal angle. This is to prove, right? Subtend equal angle is to, this you have to prove. So how is the proof? Come on, read it, beta. Read it for me.
You are
So
given
equal chords are given.
equal chords AB and CD of a circle with center O. You want to
Understood?
prove that angle AOB is equal to angle COD.
Understood?
And triangles
AOB is equal to
ABC
angle
and
COD. You
CD.
have to prove this. So how we are going to, this is the proof. We are going to start with the proof. So we are considering two triangles. And then first thing is radii. Then it is given. So with which postulate did we apply? SSS postulate, right? After that,
Yes.
from the CPCT, we can prove that this is given. So hence the proof that equal chords of the circle subtend equal angles in the center. Understood? Any doubts in this, beta?
No.
No. Okay, mashallah. So we'll see the next statement. Next to the theorem number 2. Before going to the theorem number 2, now just consider if two chords of a circle subtend equal angles at center, what can you say about the chords? Are they equal or not? For example, if in a circle, if you're going to take something and you have equal angles here and here, okay, then do you think that these chords that are here are equal?
Mm.
Yes, they will be equal because we will prove that all these triangles are congruent, right? We have already proved that these triangles are congruent. If you have this angle is equal to this angle, then we can simply prove that this is equal to this. It is nothing but converse of theorem 1. Okay, beta? Theorem 2 is converse of theorem 1. For example, what is it told is in the theorem 2, let's just consider the theorem 2, or the theorem 2, the statement is nothing but if the angles subtended by the chords of the circle at the center are equal, then the chords are equal. Is it not the converse?
Yes.
Is it not the converse of theorem 1? What does theorem 1 state? Come on, please tell me what does the theorem 1 state?
Equal chords of a circle subtend equal angle at the center.
Excellent. Now, what is the opposite of the theorem 1? The converse of the theorem 1? If the angles are equal, okay, angles subtended by the chords of the circle at the center are equal, then the chords are equal, right,
The
beta?
chords are equal. Yes.
Okay, mashallah. So this is the theorem 2. It can be easily proven by the same method, okay? You don't have to apply any other method.
Write the
Yes, beta, can you please tell me aloud?
nothing.
Okay, all fine?
Yes.
Okay, the theorem number 2 states that if the angles subtended by the chords of a circle at the center equal, then the chords are equal. Okay, so how to prove this? Let's see the proof. Let's free the proof. What to prove is just nothing. It's just the converse of that. We have to prove that AB is equal to CD. That's all. Correct, beta?
Yes.
Just a change in the postulate. Instead of SSS postulate, we can take SAS postulate. Why is the SAS postulate taken? Because we have an angle extra here, right? Radii will be equal. Radii will be equal. This will be equal to this. So we have two things here and one angle here. So which postulate did we consider? Yes, A, yes. Done? So this triangle is congruent to this triangle. If these two triangles are congruent, then what does comes into picture? From CPCT, AB is equal to CD. Is it not easy? Is it not easy, beta?
It is.
It is. Can you write it in your rough book if possible? You just write this and prove it to me, because this is not given in your textbook. This is the proof. You can write the proof.
Oh.
It's actually simple, but instead of thinking what to write in your test, you can just write it down in your rough book. We're just proving it in converse. That's it. Converse of theorem 1. Okay. Just write these concepts. 1, 2, 3, 4. Done. Okay. So we'll just quickly see the two questions that we have in 9.1 exercise. There is an exercise problem 9.1 which deals with the same kind of questions.
I'm not done, mother.
Okay, okay, please write it down. Is it done, Laiba?
Yeah.
Yes, please write it down, no problem. The figure is given, but they have not given you the reasons how you have to solve this. But it's actually easy. You can do it on your own. But it's better if you write it down. These slides will be available for you, but I'll send you whenever I finish every chapter. Okay. I think I've sent the last 2 slides as well.
Yeah.
Yes. Okay. You can refer that for your tests actually. Everything from the textbook that's important, and I've put it in the slides. And the questions do not have some space in it. You can solve the answers in it and just write out if you're going to write it on the screen and try.
Yeah.
Okay, sure.
I'm done.
Okay, mashallah. Was it easy? Theorem 1 and 2 were quite easy, right? Just we had to prove 2 things. One is an angle is equal, and one is a sides are equal. The chords are equal. These chords are equal, or the angles subtended by at the center of the circle by these chords are equal. Okay. The first in the theorem 1 you had to prove this, the angles. In theorem 2 you had to prove the sides. That's all. Okay. Okay, chalo. We'll quickly see the exercise problems. Exercise problem 9.1. And 9.1, you just have 2 problems. We'll just see the 2 problems today, inshallah, and we'll see rest of the problems in the next class. Okay. So recall that 2 circles are congruent if they have the same radii. What does congruency mean, Laiba? Laiba, what is congruency? Congruency का मतलब क्या होता है? Equal होते हैं, right?
Yes.
All the dimensions should be equal, correct? So let's draw 2 congruent circles. Okay. Is it congruent? Yes, it is almost congruent. Congruent का मतलब क्या होता है? Same radii होना चाहिए. So इसके लिए let's kind of write a radii. Let's write a point there. And just recall करने के लिए कहा है कि there are 2 circles and they are congruent. Okay. If they are congruent, if 2 circles are congruent, what do we get, Laiba? Radii are? Radius are equal in 2 circles, right? Congruent का मतलब क्या होता है? Same circles are written 2 times, correct?
Yes.
Yes. For example, if 2 triangles are congruent, then what did we prove? All the sides should be equal. If this 3, this 3, this 2, this 2, this 2, this 2, correct? All the sides, all the angles, and everything should be equal in a congruency. So the question they have told you is just this is a side point that they have told, okay? You just don't consider this. Now the question they have given is prove that the equal chords of the congruent circles subtend the equal angles at their centers. It is the same as the theorem 1, but they are asking you to prove it in different circles. Okay, how will you prove this, beta? It's quite easy. So let's draw a chord here. Let's draw a chord here. They have told that they should be equal. Okay. Okay. Statement given, Raiba?
Yes.
What is the question given, beta? Prove that equal chords of congruent circles. मतलब क्या?
Equal circles.
You should have the equal chords in 2 different circles, right, beta?
Yes.
So AB is equal to CD. Is this that they have given? This is given, okay? They have told that AB is equal to CD in 2 congruent circles. Okay, now what you're going to prove is They subtend the equal angle at their center. What you have to prove is they subtend equal angle at the center. If this point is O and this point is M, then tell me whether the angles subtended by these two chords are equal. How will you prove it better? Is it not same as the proof one? Laiba, is it not same as a theorem number one?
Yes.
Why? Because the radius are equal in the congruent circles, right?
Yes.
Congruent circles have the same dimensions, so radius are equal. So how will you prove this, beta? Let's start with the proof. Consider the triangle. Which triangles will you consider, beta? Triangle. Come on, tell me which triangles we are going to consider, Laiba. Consider the triangle AOB and the triangle. Which one? CMD, right, beta?
Yes.
Okay, now tell me what are the rules of the congruency that you can put. First rule, AB is equal to CD. Why is it? Because it is already given that they are equal chords. Next. Please tell me what next. Is it not?
Yeah.
Because radii are equal in the congruent circles. Congruent का मतलब क्या होता है? यहाँ अगर आप circle draw करोगे तो एक और circle अगर आप draw करोगे तो both circles should be equal. Equal in size. Equal in size is nothing but the radius are equal. So AO is equal to OB is equal to OB is equal to what, beta? MD. Excellent. So this is because of this reason is because of radii. Okay. Then what we can write, because of which postulate did we derive this? Which is a postulate now, beta?
SS.
Yes, postulate. From SS's postulate, we can say that what can we prove? What are we going to prove here? Angle AOB is equal to CMD because of CP. Beta, from SS's postulate, both of these triangles are congruent, correct? These congruent.
Yes.
Hence, from the CPCT, we have just put AOB to CMD. Done. This is the proof for the problem number one. If you want, you can write it down in your notebook. No problem. Do you want to write it? Laiba, do you want to write it in your book? Or is it done?
No, I'm writing.
You're writing. Okay, fine. Have you understood this bit? Is it not easy?
Yeah.
Yes, they have just told you that to prove the equal chords in the congruent circle, they subtend an equal angle at their centers. How to prove it's nothing but in the theorem 1, we had two triangles in the same circle. But here we are going to have two triangles in the different circles, but both of these circles are equal, correct? Congruent. जब congruency आती है, the concept of congruency when it comes, then the radii are always equal. Correct? We had already discussed previously. Congruency का मतलब होता है it is nothing but equality. You have to write here that these are triangle this and this are congruent because of this is postulate, okay? Because of the space constraint, I wasn't able to write here. Write about what to prove, proof, what is given. You have to write all of the statement. Given, to prove. What to prove, beta? What to prove here? The angles, right? Angles are equal. Angle AOB is equal to ACMT. So what is given, you have to write. So what is proof, you have to write. Is it done?
Yes.
Okay. So it's easy. Was it easy?
Yes.
Okay, alhamdulillah. So, Alaiba, if you have the next question saying the same as the theorem number 2, can you not prove this? It is same as the theorem 2 that you had written just previously. I want you to prove this on the board, on this one or in the rough book. Can you do this?
Yes.
Okay, please try it out, beta. Okay, we'll just consider these two circles, okay? I'll raise the parts. Okay, now can you prove this in the circles? Now tell me what is given, beta. Let's start with what is given.
The chords of the circle subtend equal angles at their center.
So angles are equal, they have already given, right? Angles are
Yes.
equal, they have given. Now what to prove, beta? To prove.
The chords are equal.
Which chord, beta? Given. So given is angle AOB is equal to angle CMD, correct?
Yes.
Okay. To prove, what to prove? AB is equal to CD, right? You have to write the statement here to prove that the chords of the circles are congruent circles are equal. Okay, congruent circles. This concept is only for the congruent circles. Okay, in theorem 1 and
Yes.
theorem 2, we have just proved for the single circle, correct? Because the statement of congruent circles came here, so we are going to draw two circles. Okay. Then
Yes.
what is the proof here, beta? How to prove? How to start with the proof? What we are going to consider at first? Consider the triangles, right? Triangles AOB and triangle what, beta? And triangle?
CMD.
Okay. Now tell me the statements that you can prove here, beta. We know that. We already know that angle AOB is equal to angle CMD. One angle we have known. Okay. Then what else? This is given. What else, beta? What else, Laiba? Radii are always equal in a congruent triangle. You should not even forget that for the blink of an eye, because in congruency, whenever congruency comes into picture, the dimension should be equal. Okay, so OA is equal to what?
MC.
Okay, then next one, beta. OB is equal to MD. You know, actually, all of these are equal. OA is equal to OB is equal to MC is equal to MD. You know it, right? All the radii are equal, but we are going to just split it so that we can show two of it, right?
Yes.
We want to have two sides here, so we are going to show it in this way. That's all. So which is the theorem that we can apply here? Postulate. Which postulate did we apply here, beta?
SS.
Yes, because side angle side, from the SCS postulate we can prove. What did we prove here? Triangle ABO is congruent to true. Triangle congruency we have proved, right? If the congruency is proven, then what comes into picture, Laiba? AB is equal to CD, right? This is only left outside, right? So C, T, C, T, right? CPCT, or right corresponding parts of the congruent triangles, right, beta?
Yes.
Understood? Any doubts on this?
No.
No. Okay, mashallah. So alhamdulillah, we are done with the class. So this was it for the today's class. So we have completed the quadrilaterals chapter entirely, and alhamdulillah, we have just completed the exercise problems and the section 9.1 of your textbook. That is nothing but the angle subtended by the chord at the center of the circle or at any point in the circle. So let's quickly summarize. And this section you have studied that a circle is the collection of all points in a plane which is equidistant from a fixed point in the middle. Okay, this is the concept of a circle. This is the definition. Do you know this? This is a definition that we have just discussed in this beginning of the class, right? Then what did we discuss in a theorem number 1, Vita? Equal chords of the circle. Or this we have proven in this one, right? Or the congruent circles. This we had proven in the exercise problem, that or of the congruent circles, they subtend equal angles at the center, right or wrong? This is a theorem number 1. Okay, theorem number 2, we have just understood that the angles subtended by two chords of a circle or of congruent circles at the center of the corresponding centers are equal to the chords are equal, then the chords are equal. This is converse of theorem 1, which is theorem number 2. Understood? Any doubts in whatever we have studied till today?
No.
No. Okay, mashallah. That's great. Barakallahu fiki. Alhamdulillah. So we've just done the recap. So any homeworks? Okay, no problem. You just study the quadrilateral chapter well, okay?
Okay.
Okay, inshallah. Jazakumullahu khairan. Assalamu alaikum wa rahmatullahi wa barakatuhu. Subhanakallahumma wa bihamdika nashhadu an la ilaha illa anta astaghfiruka wa atubu ilayk.
Walaikum assalam.